Welcome to the video on how to write the equation of a tangent line to a mathematical relation at a given point. So for this problem, we are asked to write the equation of the line tangent to x squared plus 2xy plus 4y squared equal 12 at the point 2, 1. Now recall, to write the equation of a line, what we need is first the slope, second a point that the line goes through, and then we plug that information into our point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. Let's look at the first thing, the slope. Well, recall that the slope of a tangent to a curve is given by the value of the derivative there. So the derivative is the equation that you put your values in and you get your slope of your tangent out. So what we need to do then is find the derivative of our mathematical relation. Now here, the x's and the y's are intermixed in the equation, and so the relation is implied between the x's and y's, meaning that when we do our derivative, we can use our implicit differentiation. Recall, implicit differentiation, we're going to follow all of our derivative rules, and when we're differentiating the independent variable, we will just do the derivative rule. When we are taking the derivative of the dependent variable, once we do the derivative rule, we need to multiply by dy dx for the chain rule. So let's get started. Here I'm going to differentiate term by term. The derivative of x squared is 2x, and that's the independent variable I differentiated, so we just do the rule and move on. In the next term, I have actually a multiplication of 2x, which is an expression with the independent variable, and then y, which is my dependent variable. When I'm differentiating a product of variable expressions, by the derivative rules, I have to use the product rule. So we're going to take the derivative of the first factor, and the derivative of 2x is 2, times, keep the second factor y alone, and then plus, this time we're going to leave the 2x factor the way it is, and we are going to multiply that by the derivative of that second factor y. But y is the dependent variable. So once I apply the derivative rule, I'm going to also multiply by dy dx. Well, the derivative rule for y is 1, but it's the y letter, so I multiply by dy dx. And then plus, now my last term, this 4y squared, that is a term that involves the dependent variable y. So again, we apply the derivative rule. 4 times my variable base to the number 2 power is the general power rule. So I have 8y, but it was the y letter that we were working the derivative on. So once I do that by the chain rule, I need to multiply by dy dx. And that's equal to, and the derivative of 12 on the right hand side, well, 12 is a number, it's a constant, and the derivative of a constant term is 0. Okay, so this gives us our implicit differentiation. Next, what we want to do is solve for dy dx. So I'm going to write this in a little bit friendlier manner by, within the multiplications, write that with whatever multiplications I can do out. And then we want all the terms with dy dx on one side of the equal sign, so my equal sign is there, and my 2x dy dx plus my 8y dy dx both have a dy dx in them. And any term that doesn't have the dy dx, we are going to move over to the other side. So we are going to subtract a 2x and subtract a 2y from both sides. And we will get 2x dy dx plus 8y dy dx is equal to negative 2x minus 2y. Factor out the dy dx. I have 2x plus 8y quantity times dy dx is equal to negative 2x minus 2y. And then divide both sides by what's ever multiplied to your dy dx. So dy dx is equal to negative 2x minus 2y over 2x plus 8y. Now that's the formula that gives me the slope of that mathematical relation at any point on the curve. I specifically want to know the slope at the point 2, 1. So we are going to take that derivative dy dx and we are going to evaluate it. So we do this vertical line to show we're going to evaluate it at the ordered pair 2, 1. And remember, in the ordered pair, your first coordinate's your x coordinate and your second coordinate is your y coordinate. So we're going to come over to our formula. Wherever we see an x, we're going to take it out and put in 2. Wherever we see a y, we're going to take it out and put in 1. So I have negative 2 times 2 minus 2 times 1 over 2 times 2 plus 8 times 1. So that gives me negative 4 minus 2, which is negative 6, over 4 plus 8, which is 12. And so my dy dx evaluated at 2, 1 is negative 1/2. And that is my slope of my line. Now the point is actually given to me with both coordinates. So I have my point is 2, 1. So now remember that's your x sub 1, y sub 1, and so our equation is y minus the y coordinate of the point 1 is equal to negative 1/2 times x minus the x coordinate of the point 2. Removing the parentheses, I get y minus 1 equals negative 1/2 x plus 1. Adding 1 to both sides, I get y is equal to negative 1/2 x plus 2. And that is the equation of the tangent line to x squared plus 2xy plus 4y squared equals 12 at the point 2, 1.